Welcome to this video from Derby Physics Tuition, and I'll be working with a student who's studying the thermal properties of materials, and this is a really nice question from OCR which really does test your basic understanding of the physics involved in this unit. So let's have a look at the situation. And we've got a plastic kettle filled with 0.6 kilograms of water at a temperature of 20 degrees Celsius, and the 2.2 kilowatt electric heater is used to heat the water for a time of 4 minutes. So let's have a look at how we solve part A and B. Part A, calculate the total energy supplied during the time of 4 minutes. So the energy supplied is equal to power times time, and the power of the heater, we've got to change that to watts, and the time we need to change that to seconds. So 4 minutes times 60 gives you an answer of 5.28 times 10 to the 5 joules. Okay, and it's well worth noting here in terms of exam technique that something you calculate at the beginning of a question you may well need later on. So it may well be that we need this answer for the next part of the question. So let's have a look at part B then. The specific heat capacity of water is 4,200 and the specific latent heat of vaporization of water is 2.3 times 10 to the 6, and the boiling point of water is 100 degrees Celsius. So calculate the mass of water remaining in the kettle after 4 minutes. Okay, now what we can work out first of all, in part A we calculated the total energy supplied by the heater during the time of 4 minutes. Now, what we can calculate first of all is the energy used to heat the water to 100 degrees centigrade. So the energy used to heat the water to 100 degrees Celsius. Okay, and that is our specific heat capacity formula. So the amount of energy required is mass times specific heat capacity times the change in temperature. Mass of the water is given, 0.60. Specific heat capacity is given, and the change in temperature, well, it started at 20 and it was heated to 100. So that change is 80. Which gives us an answer of 2.016 times 10 to the 5 joules. Okay, now that was the amount of energy that was used to heat the water, and the remaining energy must be used to vaporize the water. So the energy remaining to vaporize the water is the total energy supplied, which is 5.28 times 10 to the 5 take away the energy to heat the water to 100 degrees Celsius, which we have just calculated, 2.016 times 10 to the 5. Okay, and so the energy used to vaporize the water is 3.264 times 10 to the 5 joules. Okay, so we can now use our latent heat formula to calculate the mass of the water turned into vapor during this change. So do that over here, is mass times the latent heat of vaporization, which is given in the question. So if we rearrange that, the mass is the change in energy over the latent heat of vaporization. So how much energy was used to vaporize the water? That's 3.264 times 10 to the 5 joules, and the latent heat of vaporization is 2.3 times 10 to the 6 joules. Okay, which gives you an answer of 0.1419 kilograms. So that's how the mass of the water turned to vapor during this particular situation. Now the question is asking for calculate the mass of water remaining in the kettle after 4 minutes. So the mass that we had at the start is 0.6 kilograms. The mass of water turned to vapor is 0.419 kilograms, and so our final answer is 0.46 kilograms. So that answer there is the amount of water left in the kettle after 4 minutes. So this is a really good question in terms of testing your understanding of the basic ideas here, in terms of how specific heat capacity and latent heat work together in this particular question. So I really like this question, and it really is a good example, as I said, of testing your the strength of your basic understanding. So if you do have any comments or any questions, do leave them in the comments section below, and I hope you have found that this video useful. So thank you very much.